This core is from the McMurray Formation. Many of you will be familiar with the McMurray Formation because so many people have worked on it for oil and gas industry, and in particular heavy oil workers, over the last 25 years. For those of you not as familiar with the McMurray Formation, a very brief background. It's situated in northeastern Alberta, in the area of Fort McMurray, and very much in the area around Fort McMurray. It goes to the south about 150 kilometers south of Fort McMurray, and to the north another 75 kilometers or more. So it's a very large deposit. And the deposit is Cretaceous. It's Aptian and Albian in age, so let's say about 109 million years old, but it transcends a few million years. And it's generally regarded as some fluvial-tidal, or estuary deposit. And one thing's for certain is that it has a lot of point bars in it. And we're looking here at lateral accretion surfaces in the point bars of the McMurray Formation. And you can see they're very heavily bioturbated, which is why we chose these. So you'll notice first there's the black sand. It's black because it's an oil sand. It's saturated with very heavy oil. And you'll notice that the clay is a light gray to a bluish gray color. And the bioturbation is particularly accentuated around by the clay. There's a few types of trace fossils in here, but overall the trace fossils are small and they're diminutive. And they're small and they're diminutive. That's the same thing. They're small, diminutive trace fossils, and there's a low diversity of them, meaning just a narrow range of trace fossil types occurring. In this deposit, I think we have Gyrolithes, Cylindrichnus, Planolides, and Gyrolithes. And for the most part, we see them occur in just assemblages of one or two types of trace fossils. For example, just Cylindrichnus with Planolides or something like that. We can have a slightly closer look here, but we're going to look at some close-ups so you can see at this scale what some of the trace fossils look like. In many other cores as well, you'll sometimes see these mud-lined kind of horn-shaped features. Those are called cylindrichnus. That's a vertical tube. Our animal lived in the middle of that tube and lined it with mud, and it lived vertically and ate at the sediment-water interface. It grabbed food there, probably from the tides that were present in the sedimentary environment. The dots, like here, are just Planolides, and then we're going to have to look closer to look at the Gyrolithes, which kind of perforate the core here and there, where there's a lot of high-intensity perforations. We'll get a closer look at that and see the Gyrolithes. And also there's going to be a closer look at the Gyrolithes. And one other trace fossil I will point out here is this large arthropod burrow here. This is Cylindrichnus. That's probably the tunnel of an animal like a crab. So that's pretty cool. Here we're looking at a close-up of the core such that we're really seeing Cylindrichnus. And the Cylindrichnus are these mud-lined burrows, and if you look carefully at a few of them, you'll see there's a sand-filled burrow that goes up the middle of these. So what we're seeing is a two-dimensional view exposed by the slabbing of the core, and in this case you're catching most of the lining. Here again is a lining with a burrow in the middle. That's called the causative burrow. There's other trace fossils in here, like these sand-filled oblique trace fossils that might be Gyrolithes. That's a U-shaped burrow, but we have a better example later on. And for sure, these sand-filled tunnels here that are Planolides. Cylindrichnus is made by an animal that lives vertically in the burrow and feeds at the sediment-water interface from food delivered by tides. We call this interface deposit feeding, and the animal that did that looks something like this. This is a terebellid polychaete, and they live vertically in the water and in similar burrows. This one was living in sand, you can see, and they have this tentacular mass at their mouth, and they spread those tentacles out over the sediment-water interface and gather and catch food into their tentacles. Now let's look at Gyrolithes and Gyrolithes. Aeronicolites and Gyrolithes. First, the simple one, U-shaped burrows, like you see here, kind of poorly formed, but these shallow U's. That's probably Aeronicolites. You don't see the whole U because it's a two-dimensional exposure, so you're getting a random cut through a U-shaped burrow that's filled with sand. The Gyrolithes in this bit of core is a little bit debatable, but we're looking for these paired dots that represent a coil, or think of something like the spring on a Bic pen where it wraps around, and that's what a Gyrolithes looks like. It's a burrow that really helically spirals upwards to the sediment water interface. And quite often in the McMurray Formation, when you get Gyrolithes in the deposit, you start to get these kind of scattered zones where a whole bunch of perforations show up, but you're not always sure what you're looking at. But I think these are even Gyrolithes here, although it might be debatable. The Aeronicolites is a U-shaped burrow, and it's made by a worm called Aeronicola. There's other trace fossils for Aeronicolites as a simple U-shaped burrows. Almost any worm and small arthropods are capable of making it. But here's an example of Aeronicola, which is a very common U-shaped burrow maker. In fact, this is the worm that Aeronicolites gets its name from because it lives in these broad U's and sand flats. And some of you that have been on field trips out to the coast have seen these. Now let's go back all the way to the core images here, and you'll see all of this bioturbation here. Remember, I said it's diminutive. They're small burrows compared to some of the things we've seen in the other core displays, right? And the diversity's pretty low. And even at certain beds, some of these only have one ichnospecies, or some of them only have two ichnospecies. And together, these are burrows that Pemberton wrote a paper on in 1982 or so, or was it 83? Gosh, I should know that. In Science, that is a paper about the trace fossils of the McMurray Formation, where he interpreted all of these as brackish water assemblages, meaning indicative of salinity between fresh and marine waters and in a mixing zone. And that's why a lot of workers refer to these aspects of the McMurray Formation as an estuary, because brackish water resides in these channels that have laterally accreting bars. Okay, thank you.